Okay, so I apologize, but Miss Levinson, you can blame her. She interrupted me, and since there is no pause button on this stupid thing that at least I can figure out, I gotta stop and start again. Okay, so back to this. So what does this mean? Since f of x is above the x-axis, it means that f of x is increasing. And this tells us, this number, that 8, this tells us how much f of x increased on that interval. So again, we know derivative graphs, if they're above the x-axis, again, tells us that the original function was increasing. And the value then that we actually get is that 8 tells us how much it increased on the interval from 1 to 3. So kind of an important piece of information. Okay, so let's look at a similar idea with two different functions. So I've got the functions g of x equals x minus 3, g of x equals 1/2 x squared minus 3x minus 4. So again, if you notice, if I take the derivative of this function, it's going to give me this function, which means if I integrate this function, I would get this function. Well, I would get a possible of this function. I need a value to find my plus c. So very similarly to what we did before, the relationship between lowercase g of x and uppercase g of x is again that we took the derivative of this, we would get this. And if we would integrate this, where am I going from? What to what? G of x. We would get this. Okay. All right. So we want to do the graphical representation from 2 to 8 of g of x. So again, since we've got this function, we're integrating. We want that area under the curve between the curve and the x-axis. So from 2, I'm actually down here, and then to 8, I'm here. Take a moment, I'll color all this good stuff in. Okay. So then we're going to evaluate it. Again, what's really nice about this picture, like the one that we had before, I don't need to use rectangles and Riemann sums and all that stuff to estimate the area under the curve. I can actually find it because both of my regions are geometrical figures. They are just triangles. We know the area of a triangle is 1/2 the base times the height. And better yet, these are all nice right triangles. Okay, so we've got two triangles we have to find the area of, and the fact that some of our region is under the x-axis versus above is extremely important. Since we're going to be below the x-axis, this signed area here is going to be negative, and this signed area here is going to be positive. So important to keep in mind. All right, so to find the area of this region right here, I'll call it the area of triangle 1, 1/2, we've got base and a height of 1. And again, since we're under the x-axis, that would make that negative 1/2. The area of region 2, which we'll call up here, that's going to get me 1/2, base 1, 2, 3, 4, 5, height 1, 2, 3, 4, 5. It's above the x-axis, so it'd be positive. That's going to get me 25 halves, or 12.5. So if I was going to evaluate the region, we're going to take the sum of these two regions. So negative 1/2 plus 12.5 gives us a value of 12. Basically a net accumulation. Again, when you've got those negative areas underneath there, this is our accumulation of our area as we go from point 2 to 8. Okay, so now we're going to look at it and see what does it look like on the original function. We're going to do the graphical representation again of g of 8 minus g of 2. G of 8 and G of 2 are just the y values at 8 and 2. So at 8, it looks like I'm up here at 4. And at G of 2, I happen to be negative 8. If I bring that over here, so that graphical representation is I'm looking for that change in G of X from positive 2 to 8. So to evaluate it, well, G of 8 happens to be 4 minus G of 2, which is at negative 8. Lo and behold, again, shouldn't be a coincidence. We actually got the same value. That's slightly annoying. Okay, so our conclusion should be the same conclusion we had from before, that G of 8 minus G of 2 is the same as your integral from 2 to 8. This area here, this region under the curve, again, is representing the change. Tells us how much we've changed from 2 to 4. So I'll write that down, the area under the curve. Represents the change of G of X on the interval from 2 to 8. All right. Let's use different paper.